Welcome to BKW Physics. I'm Mr. McConley, and today we're going to cover the topics of precision and accuracy. So let's start with precision. This is a word that's commonly used in the English language. Oh, I'm very precise. High precision. But there's another word that we're going to talk about also today, accuracy. In the English language, a lot of times these two, the definitions kind of get overlapped. You know, if you have high precision, a lot of times you're highly accurate, and they kind of almost mean the same thing. But in physics and in science, they do mean slightly different things, and there's a different way to account for each one of them. So I like to explain it this way. Precision is how reproducible the results are. So if you can reproduce the same result over and over and over again, that's precise. So it's reproducibility of results. It's also can be thought of like this. If a bunch of people measure the thickness of something, the thickness of a textbook or whatever, and one person measures it as 1.54 centimeters, and another person measures it as 1.55 centimeters, and another person measures it at 1.57 centimeters, and the last person measures it at 1.41 centimeters. You're going to look at that and immediately think like, what is that person thinking? Because pretty much, you know, these people kind of agree, they're off a little bit, they kind of agree, and that person's just, there we go. Okay, so that's, you would probably say, this person's not being very precise. But there's a way to kind of account for it in physics, and we've already talked about it a little bit when we talked about significant digits and whatnot, but I'll remind you of it. When you measure something, the last digit of your measurement is a guess. Because you could definitely tell this was true, you could definitely tell this was true, but this one was open to interpretation because there weren't really any lines on the ruler that went down to the hundredths place. So you were guesstimating that one. And because that's a guess, the way we account for precision is we can say that this number here really falls within a range. And the range of that number is somewhere plus or minus 2 in the guess place. So we did this in lab earlier. So this could be anywhere from 1.52 centimeters all the way up through 1.56 centimeters. So that's the range of values right there. And now you can kind of start to see how you can test the precision a little bit more exactly. Because you can say, this is the range. You can set up a range for this one, 1.53 all the way up to 1.57. And the range for this one here would be 1.55, 1.59. And now you can start to ask yourself, do these numbers overlap? And there was a question in lab about this. So would you say, if these numbers are overlapping, you could say that this was very precise data, at least the first 3 people, right? Do the numbers overlap? Yeah. So since the numbers overlap, you would say that this is precise. If we added in this one with the range, now this group of data becomes imprecise because this person's way out in left field. I think they read the ruler wrong. Okay, that's precision. Now accuracy is a different sort of beast, because accuracy, you're not comparing the numbers to each other, you're comparing them to something that somebody else or everybody else agrees is the correct value. Explain it this way. When we talk about the acceleration of gravity in a short while in this class, we're going to all agree that the acceleration of gravity is 9.81 meters per second squared. That's an accepted thing. So if you're doing a lab, and you come up with 10.1 meters per second squared when you get the acceleration of gravity, the question arises, are you accurate or not? If it's supposed to be 9.81 and you get 10.1, are you accurate or not? And there's a way to test accuracy. You know, because it's kind of hard to gauge this if you just, you know, off the top of your head, it's hard to gauge it. So there's actually an equation that most everybody has used, but I'll remind you of. It's the percent error equation, which says you take your observed value, you subtract your accepted value, that's all over the accepted value, and then if you times it by 100 at the end, that's going to make it into a percent. So, if you were to plug these in, being that this is your observed, this is your observed value, and this is your accepted value, and you were to plug that in, you could say by what percent you deviate from the accepted value, and then you could say how accurate it was. You could say this is accurate within 5%, this is accurate within 1%. And the smaller the percent is, the more accurate you were. Does that make sense? The difference between precision and accuracy? Okay. And for today, physics.